Good day everyone, my name is Jeneline Ibanez Balboa, and for the continuation of the Group 1, I will be discussing the Lesson 1.5, the measures of skewness. But before that, these are our lesson objectives. So number 1, define measures of skewness. Number 2, understand the formulas used to calculate skewness. Number 3, identify the types of skewness, positive, negative, or normal distribution. And the last one, calculate skewness using appropriate formula from a given data set. Alright, so what is measures of skewness? So, the measure of skewness describes the degree of departure of the scores from the symmetry, right? The skewness of a score distribution only tells about the performance of the students, but not the reason about their performance. Only tells their performance. Okay, so let's proceed to the formula of the skewness. So this is the formula of measures of skewness. Sk is equal to 3x minus x over s, where the x is the mean value and the another x would be the median value, and this is constant, right? This is the formula of the measures of skewness. Later on, we're going to use this formula to solve the problem. Skewness can be classified according to the skewness coefficient. For positively skewed, skewed to the right, this means that the thin end tail of the curve goes to the right part of the distribution. And then for the negatively skewed, the skewed to the left, meaning the thin end tail of the curve goes to the left part of the distribution. While the normal distribution, the scores are normally distributed. So that means the value of the mean, median, and the mode are equal. While for positive skew or positively skewed, the mean value is greater than the median and the mode value. So like for example, mean is equal to 50, median is equal to 47, and the mode is equal to 43. And for negatively skewed, the mean value is less than the median and the mode value. So for example, the mean is 43, median is equal to 47, and the mode is equal to 50. So for positively skewed, most of the scores are low. Hence, most of the students got scores below the mean value. So this is the positively skewed. And the negatively skewed, the most of the scores are high. Hence, most of the students got scores above the mean value. So this is the difference between the positively skewed, negatively skewed, and the normal distribution or no skewed. Alright, as you can see the picture, the negatively skewed, the tail go to the left of the distribution, while the positively skewed, the tail go to the left distribution, and the normal distribution is in the middle or equal. So this is the normal or no skew. Alright, so for positive skewed, poor performance of the students, this could be attributed to the following. So first, ineffective methods of teaching and instruction. So in order for them to understand, so you have to change your teaching style, okay, so they can catch up the lesson. Alright, so yeah. Number 2, students are not ready to take the examination. So this is also the reason, okay, for their poor performance. So maybe they're not ready and didn't study their lesson, so and that's why they're not ready to take the examination and got the lowest score. Right, so for number 3, test items are very difficult. So maybe they felt difficult, that's why they get lowest score. So that's the reason why they are have poor performance. Okay, and then for number 4, the time given to answer the test question is not enough. So like for example, the test questions are 50 items and you only give them at least 30 minutes, so the time is not enough. So that's the reason why they got the poor performance. So that's it. So for negatively skewed, outstanding performance of the students. The performance of the students could be attributed to the following. So number 1, the group of students are intelligent, right? So they are intelligent. They easy to catch up the lesson. Number 2, there is enough time to finish the examination. So the time allotted is enough for them to answer all the questions. Number 3, very easy test items. So they felt it's just easy, so they got the high score. And the number 4, effective instruction. If effective instruction, it means that they understand your instruction. And number 5, students prepared themselves for the examination, so they are well prepared, so they don't feel nervous, and that's the reason why they got the high score. So that is right. So for the normal distribution, most of the students got a score within the mean value. Hence, most of the students have average performance. About 68.26% of the students in the group have average performance, though they are equal. So there is no skewed, and this is the normal distribution. Alright, using the formula, let's find the coefficient of skewness of the scores of 30 grade 4 students in a 45-item test in mathematics. So the mean is 38.50, the median is 32.25, and the standard deviation is 2.50. So the given is the mean is 38.50, the median is equal to 35.25, and the standard deviation is equal to 2.50. So using our constant formula, we have to distribute the mean and the median. So the mean is 38.50 minus the median is equal to 35.25 divided by the standard deviation, which is the 2.50. So it's equal to 38.50 minus 35.25 is equal to 3.25. Copy the constant 3 and then divided by 2.50. So 3 times 3.25 is equal to 9.75 divided by the standard deviation of 2.50. The answer is the SK would be equal to 3.9 or positive 3.9. Right? Right, let's have another example of measure of skewness. Okay, so find the coefficient skewness of the score of 30 grade 6 pupils in a 45-item test in Makabayan. The mean is 39.50 and the median is 42.50 and the standard deviation is 3.25. So our given data set, the mean is 39.50 and the median is equal to 42.50 and the standard deviation is 3.25. So using the formula, we're going to distribute the mean and the median. So 39.50 minus 42.50 is equal to negative 3. Okay? Negative 3 divided by the standard deviation, which is the 3.25. The answer is the skew is equal to negative 0.92, which means this is the high score. Okay? Negatively skewed means that most of the students got the highest score. Unlike for the positively skewed, more of the students got the lowest score. Okay. Alright, let's proceed to the normal distribution. Let us evaluate the area under the normal curve between the mean and the standard deviation as indicated in the diagram. Alright, so the percentage of cases that fall between the mean value and the value of the mean plus the value of one standard deviation unit in the normal distribution of scores is 34.13%. Whereas the percentage of cases that fall between the mean value of the mean minus the value of the standard deviation is 34.13%. So, hence, the percentage of the distribution of negative and positive one standard deviation from the mean is 68.26%. So, you just add the 34.13% and the another 34.13%. The result is 68.26%. Now, the positive and negative 2 standard deviation from the mean value is 94.44%. And the negative and positive standard deviation from the mean is 99.72%. When you add the percentage of the baseline between 4 standard deviation units above and 4 standard deviation units below, we get the sum of 99.98%. So there are still scores beyond positive and negative 4 standard deviation from the mean, which is equal to 0.02% to make the area under the normal curve equal to 100%. So that was the normal distribution. So I guess that would be all, and thank you so much.